Okay, so we're all familiar with like normal programs written like Java, Python, C++, whatever. But there are also programs that are written in high-level languages that are called assembly languages. And these assembly languages, the assembly language programs, are compiled and turned into machine language programs, which consist of only sequences of ones and zeros. And even though there are a lot of good compilers out there, it's still important for us to understand how assembly language works. Uh, ACSL doesn't use any specific assembly language, like any real assembly language, so they like make their own, so that they don't have to deal with all the details of the specific languages. So execution of an assembly language program will start at the first line of the program, and it will continue sequentially unless it sees a branch instruction, which is like BG, BE, BL, or BU, and I'll go into what those mean later, or until the end instruction is encountered when the program will terminate. And the result of each operation that the program will do is stored in a special like location of memory called the accumulator, which is abbreviated ACC. And the accumulator begins with an initial value of 0. And the format of every line of an assembly language program is label, opcode, and lock. And the label field, if it's present, which it's not always, is just like a word, an alphanumeric character that's in the first column, and it has to begin with an alphabetical character, either capital or lowercase, and all the labels are case sensitive. Opcodes are specific operation, like abbreviations of operations for the program, and these are also case sensitive and uppercase, and these are reserved keywords, so they can't be used as a label. And the third parameter in every line of an assembly language program is the lock field, which is either a reference to a label or immediate data. So if you have load A, that means you're putting the contents of what's in the accumulator right now into the memory address referenced by A. And then if you have, for example, load equals 123, you're going to store the literal value 123 in the accumulator. Yeah, so the label is like a variable, and we'll show an example in a few slides. But it can also be used to reference like a go-to statement. So like when you branch, you'll do like branch like BU and then the label, and it'll go back to the line where that label is referenced first. So these are all the different opcodes. So we have load, which will place the contents of whatever lock variable holds into the accumulator, but it does not change the lock variable. Then we have store, where whatever's in the accumulator will be placed into the lock without changing what's in the accumulator. Then we have the 4 basic math operations: add, subtract, multiply, divide, which is obvious what they do, and they don't change the lock variable, and the result of the operation is stored in the accumulator. Then we have the 4 branch operations. We have BG, which means that it will branch to the instruction labeled with lock if the accumulator's value is greater than 0. BE, it's the same thing except if the accumulator is equal to 0. BL if it's less than 0. And BU, it will branch to the instruction regardless of whatever the value of the accumulator is. Then we have input output. So read, it will read in assigned integer into the location variable. Print will print the content of the location variable. Then DC you use to define a variable to a specific value or to a specific constant. And then end will terminate the program when it's encountered. So this is the first sample program. So we have, wait, how do you write? We have temp, I'll just use t, and it's equal to 0. We have a, which is, oh my god, this is so hard. 8. Sorry if it's hard to read. B is -2. Okay, this is horrible. I'm just not gonna write. B is equal to -2. C is equal to 3. So I'll actually write in what's in the accumulator. So So first we're loading the contents of B into the accumulator. So that's going to be -2. Then we're going to multiply by the value in C, which is 3. Okay, this is actually not possible. Okay, so the accumulator, we have -2. And then we're going to multiply by the value in C, which is 3. So we have -6 in the accumulator now. And then we're going to add the value in A, which is 8. So now the accumulator holds 2. And then we divide by -2, which will be -1. And then we're going to subtract what's in A, which is 8. So we're going to have -9 as our final answer. And yeah, this just goes over what I just said. So -9 will be stored in temp. And that's what the question is asking for. So there's our answer. Our second sample problem. So if we input the value n into this assembly language program, so lock is like the third column, right? So temp is like the location, so it's storing whatever values in the accumulator into that variable name. Okay, so we read in a signed integer x, and we're loading that value into the accumulator. Here's where we're using a label for a branch instruction, like down here. When we encounter this, we're gonna branch back to this. So we take what we have in the accumulator and we subtract 1. So now we have x minus 1 in the accumulator. And then we encounter this branch instruction, BE, and our thing is not equal to 0. So we don't branch to the done. Now we store what we have into A. So A is going to hold x minus 1. And then we multiply what's in the accumulator by x. So in the accumulator, we have x minus 1 times x. And then we store that result into the variable x. So now x is x times x minus 1, or n times n minus 1. And then we're going to load the contents of A, which is x minus 1 right now, into the accumulator. And then we encounter this BU instruction. So we go back to this line. So we have subtract 1 more. So we have x minus 2 in the accumulator now. And then it's still not 0. So we store x minus 2 in A. We multiply what's in the accumulator right now, which is x minus 1 times x, by x minus 2. And then we store that into x. And then we load x minus 2 into A. And this will keep going until you reach the point where this instruction is true, which is when the accumulator holds 0. So this will just keep on going. You'll have like x times x minus 1 times x minus 2 until 2 times 1. And that's just equal to x factorial. But since our input here is n, x is going to be equal to n factorial. And here is just like a paragraph explaining, if you want to read that. Are there any questions?
Okay, so that's it for our review session today. If you guys have any questions right now, you can ask us real quick, and we already posted the lecture, so you guys can look through that. So yeah, if you have any,
we'll post the stuff that Miss Kim talked about at the beginning on Facebook soon.
Yeah.
Miss Kim, is there anything you wanted to tell them?